Welcome to our new section on nomenclature. I just wanted to start it with something a little bit interesting, and that is this picture of some different items. Think about what's in a name. Can you find the bonnet? Can you find the boot? Well, we might be pointing to the bonnet and the boot, but you know what? People in England would be pointing to something different. The bonnet, to them, would be the hood of the car, and a boot, they would think, was the trunk of the car. So I just pointed that out to let us all think a little bit about how important it is that we're naming things the same thing and in the same way. So that's really important when it comes to science and when it comes to chemistry. Nomenclature is simply a system of naming compounds. Compounds, if you'll just remember a quick review, are two or more atoms of different elements bonded together. And just a little FYI, even though the gases of oxygen, nitrogen, and fluorine, chlorine, they travel diatomically in pairs, their names are simply oxygen, nitrogen, fluorine, and chlorine. Even though they are molecules, we just call them by their elemental name. So what is a binary ionic compound? That's what we're going to learn how to name. Well, binary means two. It's something that contains two elements. And an ionic compound, it contains a cation, which is written first, and an anion. We're going to look at three types of binary ionic compounds. The first type, type 1. It's pretty simple. It is a compound that exists between a metal and a nonmetal. The metal in type 1 binary ionic compounds can only form one cation. Examples: sodium, aluminum, calcium. Sodium always forms a +1 cation. Aluminum always forms a +3. Calcium always forms a +2. When we talk about type 2 binary ionic compounds, however, those are between a metal and a nonmetal, but the metal in those can form two or more cations that have different charges. An example would be copper. Copper can form a +1 cation, and sometimes it's +2. Now, just a rule of thumb, type 1 binary ionic compounds in group 1 and group 2 of the periodic table, they always form either a +1 or a +2. Aluminum forms a +3. Sometimes it can be a little bit different. Examples of type 2 binary ionic compounds: transition metals. Those vary a lot, usually. Sometimes there are transition metals that will just have one charge, but transition metals oftentimes form cations that have that can be different charges. Type 3 binary compounds is the very last one we're going to learn how to name, and they contain only nonmetals. So let's start with type 1. Remember, type 1 binary ionic compounds between a nonmetal and a metal, and the metal can only form one cation. It's a definite one choice. You don't have multiple choices there. We name the cation first, and we name the anion second. Here are our rules. A cation of a single atom is named after the element. For example, the sodium is just called sodium. That's what we do with the cation. And then when we name the anion, it's named by taking the first part of the element name, the root, and adding an IDE on the end. So here's an example. Chlorine, when it becomes the ion, the anion, we call it chloride. Put an IDE on that root chlor. So here are some examples. Sodium, here we have a sodium element, a chlorine element. The ions that are present here are the sodium ion and the chloride ion. So we name this sodium after the element for the cation, and chloride. Take the root and add an IDE for the anion. Let's try this compound. We have calcium cation present and a sulfide anion present. This is called calcium, that we name for the cation, and sulfide is sulf, the root word, and we put an IDE on it. Now you try. Name that compound. This would be the ions. These would be the ions present. There are 2 iodide ions, and the name of that compound is magnesium iodide. Now, let's look at type 2. Type 1 is pretty simple. Type 2 is a little bit more complicated. Type 2 binary ionic compounds, remember, the metal in them can form 2 or more cations that have different charges. So how do we know if the metal can form 2 or more cations that have different charges? And like we said, group 1 and group 2 metals are always type 1. That's a definite. Transition metals are usually type 2. So here are some common type 2 cations. You can see iron. It can form a +3 ion or a +2 ion. Copper can form a +1 or a +2. We have tin, could form +4 or +2. Those are some different cations that can be formed. You will not have to memorize those. So I just wanted to put your mind at rest. You don't have to memorize them, but you just need to keep in mind that transition metals often and usually have multiple different cations that they can form. So let's talk about the rules for naming these type 2 binary compounds. Rules. They start out the same as type 1. We name the cation first, the anion second. And again, it's just like in type 1, a cation is named of a single atom is named after that element. So again, the example, sodium is called sodium. An anion of a single atom is named by taking the first part of the element name and adding IDE, much the same way. So actually identically to the same way as type 1. So we take the root and we add IDE. Now here's where we differ. We now need to find the charge of the cation. How do we do this? Type 2, finding the charge on the cation. Let's do this by example. Let's take this compound, okay? Let's take the iron. The iron, when it becomes a cation, we don't know what its charge is going to be because remember, it's a transition metal. We have a few different choices for the charge on that iron, and we don't know what it's going to be. Let's take the chloride, all right? We have the charge on chloride is a -1, and there are 2 of them. See, we have 2 chloride ions. So if this is a -2, what does the charge on the iron cation need to be in order to total a net charge of 0, have a total net charge of 0? Well, it needs to be +2 because +2 minus 2 equals 0. Now, that means that iron as a cation will have a +2 charge. You try the next one. Try this compound and see what you can come up with for the charge of the cation for lead. So the charge of the cation for lead is going to be, we'll set it up the same, big question mark, some charge. We know that oxide has a -2 charge, and there are 2 of them. That gives us a total of -4 here. Lead must be a +4 in order for our net charge to be 0. So the charge on the lead cation must be +4. Here are a few more for you to try. If you want to pause the video, you can try those and see if you get them right. Here are the answers. Right here, for the copper and the chloride, the charge on the copper must be +1. For the iron and the sulfur, this one's a little different because we have 2 irons. So we write it like this: 2 times some unknown positive charge plus our sulfur. We have 3 of them, and they are -2 each of the anions. So 2 times what number minus 3 times a -2 is going to give us 0. We know that the answer must be +3. Iron, each of the iron atoms has a +3 charge. So let's go back to our rules. What are we going to do with this information now? So we've already gone through the first 3 rules, and number 4, we've just found out how to find the charge of the cation. What are we going to do with that information? We are going to name our compound using a Roman numeral after that cation, and that will represent its charge. Here's an example. Copper chloride. We are going to name it, remember earlier we found that the copper cation is +1 in this example. We are going to name this compound like this: copper, and then a Roman numeral 1, chloride. And the Roman numeral 1 is in parentheses. This tells us that the copper is +1 charge. Its anion in this particular compound is a +1 charge, and that is how we name it. And we say it, copper 1 chloride. Okay, here are some examples, and I just realized that I made a mistake there. I have the wrong name in for these compounds. The charge on the lead cation in this compound is +4. We found that earlier in some of our examples. So when we name it lead 4 oxide. And this is how we write the 4. We write it in Roman numerals in parentheses. That tells us that the lead in this compound has a +4 cationic charge. Now, what's the charge on iron in this compound? We found earlier it was a +3. So we name it iron 3 sulfide. And that's how we write that. Now we're going to look at one more type of binary compound, type 3. Remember, type 3 binary compounds contain only non-metals. Here are the rules. We name the first element in the formula first, using the element name. Second, we name the second element as though it were an anion. So we use the root name of the element and add an IDE. Very similar so far. Third, we use prefixes to denote the numbers of atoms present for each element. So let's jump down here to an example. We have boron and fluorine represented. And here's another mistake. That 3 should be a subscript, indicating that there are 3 fluorine atoms in this compound. So we name it by, remember, using the element name for the first element, boron. We use the element, we're going to name the second element as though it were an anion. So we're going to name it fluoride. But we're going to use a prefix because there are 3 fluorines. We're going to call this boron trifluoride because there are 3 fluorines. Let's look at this compound. We're going to call this compound dinitrogen because there are 2 nitrogens. Pentoxide for 5 oxide. That makes sense. One important item to note here is that if there is only one element in the first that comes first in the compound, we do not say mono for the very first one. We do say mono for the second one. So here we're going to drop the mono on the first and call it nitrogen, and then we'll add it to the second element, and it will be nitrogen monoxide because there is only one. And that is how we name type 3 binary compounds. Here's a little bit of review for you. If this is helpful, you can pause this and use this to help you remember how to name binary compounds. I've listed 1, 2, and 3 again, just as review. You can ask yourself, is it a binary compound? Well, if it is there a metal present? If there's no metal present, remember we're going to name it as the type 3, and we're going to be using prefixes. If there is a metal present, we'll ask ourselves, well, does that metal form more than one cation? If it does not, if it only forms one cation, it's going to be type 2, and we use the element name for the cation. If that metal does form more than one cation, we're going to use the type 2 naming conventions where we use Roman numerals in the element name. Hopefully that is helpful. And if you want advanced proficiency, I'm going to ask you to really be creative, use your imagination, come up with some good ideas of what you might do, and make sure you get a worksheet so we can practice some of these naming conventions, and I'll see you in class.